Hello everyone, welcome to video 6 of my GNAI series. Today I am going to talk about something very interesting. So we have already learned about what an LLM is, but we are going to learn what an agentic system design is. An LLM is something which answer questions like a chatbot. Now an LLM that can call your APIs, read your database, run code and make multi-step decisions is an agent. Agents are where the real enterprise value is, and they are also where things can go wrong and very hard to debug. This video covers the full design, React loop, tool design, multi-agent orchestration and the guardrails you need before your code touches in production. So without wasting time, let's get started. Now we'll see what an agent is. So first, what an LLM is, right? This is a single LLM call. LLM is a large language model where you can query and get an answer. It is stateless and in one shot we can get the answer. But agent is something which runs in a loop where we get first query and then it comes to LLM, LLM gives reason and then eventually depending on the result of that reason again another tool gets called, then again reason, then tool gets called, again reason till we reach an endpoint. So in this case the endpoint is payment not possible, insufficient fund. So basically the agent decides which tools to call in what order based on intermediate results. We don't hard code the flow, the model orchestrates it. Let's understand a very important pattern in agentic system, that is called React pattern. So React is basically reasoning plus acting. The foundational agent pattern every serious framework implements. The loop runs until the model decides it has enough information. We set the max iteration, the model decides when it's done or the max iteration is hit. So this is an example of a React loop. So thought, first there would be a thought, right? The thought is what do I need to do, and the action would be a tool with argument call, and then we get the some result for that from that tool called which is the observation, and then again thought what next, and then action, and then we get the final answer. We can see this with an example. So an example can be whether in Paris need a coat. So this is the thought. So this is the question. Now the thought would be I need the current weather, right? So action would be get weather with city equal to Paris. This is something, a function which is already written. The observation of this action is temperature equal to 40, rain and then 25 kilometer is the speed. So thought then is 14 degrees centigrade, rain, wind, coat is needed. So we get an answer that yes, bring a coat as it is 14 degree centigrade with rain and wind in Paris. So this is example of a React pattern. Now we will see what are the 3 rules which we should follow while designing the tools following the React pattern. Tools are where the agents fail because we don't design it properly. So we have to design it properly following this principle, like narrow scope, because one tool should have one job, not a generic job. Some example of it is, let's say we have a tool where we have do database stuff is the name of the tool, and then what it does it query for object and the query is passed as parameter. So this is a bad tool because it is too broad and unpredictable. What is a good tool is, good tool we get account balance is a good tool because the tool name is get account balance, and what it does is it takes the user ID and then queries our repository with that ID and get the account balance. If not, then it throws a string that account not found for that particular user ID. So this is the first thing. Second is we should have explicit type schema, every parameter is validated. Third is deterministic behavior, bounded limits, no raw, SQL or cell. So here we can see that we have a bounded limit. The example is if limit is greater than equal to 30, then throw new tool exception, limit cannot be exceeding 50. So this is like bounded. So the rule here which we should keep in mind that every tool input is validated, which we saw here like for the user ID, right, for the limit, every tool input is getting validated, every tool output is typed, either it is string or either it is some integer or anything like typed, it should not be unbounded. And tool should never accept raw SQL, raw cell commands or anything that model constructs dynamically, so that it doesn't stay generic. Now we will see implementation for a particular agent loop. So there are three things which are important for implementing an agent loop. We should have a bounded loop. So a capped for loop that calls the agent, checks the finish region, executes the tool and feeds the result back until the model returns a final answer. So three things are important as I discussed. Stop is where agent has its final answer, returns it. Tool calls where we execute the tools, append the result and loop again. Hit max iteration and then return a graceful fallback message that agent is not able to find within max iteration. We will see it in an example also. Here we have defined max iteration is 10 and I am running it inside a loop that if my I is less than max iteration, then what we do is we get the response, we basically call the our APIs, and eventually if we get the response as response dot finish region as stop, then we return the response. If it is not stop, if it is tool calls, then we do add the message, basically response of the previous call, and then call the executor again, so that the loop gets called again. So in this way it will continue till we get the answer. For system prompt there is a constraint that we should stop and ask the user if more than 2 call produce unexpected result, a built-in circuit breaker against a runaway loops. Now for multi-agent we would be seeing two patterns, the pattern 1 and pattern 2. Pattern 1 is orchestrator and worker pattern. So here we have an orchestrator agent and then there are many worker agents like research agent, writer agent, reviewer agent, and these workers they don't talk to each other, only they talk to orchestrator, and orchestrator gives the instruction to individual agent. It is used when long task and parallel execution, so that no workers talk to each other. And pattern 2 is supervisor and specialist. Here user talks to supervisor agent and then supervisor agent routes it to different specialist agent like support, sales, technical. So supervisor basically clarifies the intent and then it hands it off, and when a specialist agent need information from another specialist agent, they can talk with each other. It is used when task type need different tools. So why do we use multi-agent is single agent hits limit, context window fills up and task gets too complex. So you need specialization, and that is the reason this two pattern solves the problem. Now to execute any agent in production, we should have some guardrails. There are three required layers for this guardrail. First is input validation, which catches any prompt injection before it reaches the agent, and output validation, which is catching hallucinations, PII leaks, format violations, etc. And third is human in the loop, where it pauses and asks before irreversible action. So we will see first input validation. Input validation is something which catches prompt injection. So if user message length is greater than this or anything like that, we can just write our logic and then validate the input. The output validation is where we do validate our agent response contains any PII or any restriction like GDPR or anything which can be which should not be outputted, that we can have in output validation. Third is the most important thing, which is human in the loop. So it sometimes pauses and asks before irreversible action. We can see it while using like Claude agents or any other agent, that it asks you want to do it, yes or no. So this is basically human in the loop, where we require approval from a human for irreversible action. For examples are delete account, process refund, send email, update permissions, and if these things are there, then it would require a human approval. So we need to understand that this human approval is not optional. The agent pauses and surfaces the action to an human and waits for approval before executing anything which is irreversible. So to close it, agent is something which is LLM plus tools plus a loop, and the things which we have learned here is React gives you the pattern, narrow tools gives you safety, every serious agent framework implements reason, act and observe. Multi-agent gives you scale, orchestrator workers for parallel tasks, supervisor specialist for different task types. Guardrails give you production readiness. We should start with human in the loop on every irreversible action and loosen from there as you build the confidence.